A1n in first row. In matrix first row, A11, A12 up to A1n. So next second row, A21, A22 up to A2n. So this is second row. And last row, AN1, AN2 up to AMN. So this is last row. And unknowns x1, x2, x3 up to xn. And so these are constants b1, b2 up to bn. So given system of equations in matrix form. So that is AX is equals to B form. AX is equals to B form. So this is A matrix. So this is A matrix, X matrix, and B matrix. So now we have to find out the solution of equation AX is equals to B. So that is X is equals to A inverse into B. So A matrix inverse. Inverse is nothing but if inverse exists only if determinant is not is equals to 0. If determinant is not is equals to 0. The determinant is not is equal to 0. The solution of equation to Ax is equal to 0 is X is equals to A inverse into B. So this is the solution. So in Gauss-Jordan method, example 1. Solve the system of linear equations by using Gauss-Jordan elimination method. So in Gauss-Jordan elimination method, so these are given system of equations. So these are given system of 4 equations with 4 unknowns. 4 system of equations with 4 unknowns. So that is so system of equations in matrix form. So there is no x1. It starts from x2. There is no x3, x4. So first equation. So x1, there is no x1. So we can take 0. x2 coefficient 2, x3 0, x4 1, and is equals to 0. Next, x1 coefficient 2, x2 coefficient 2, x3 3, x4 2, and constant minus 2. So this is second row. Next, similarly, third row, 4, minus 2, minus 3. There is no x3, 0, and x4, 1 is equals to minus 7. So next, 6, 1, minus 6, minus 5, 6. So this is fourth row. So, but first we have to convert the given matrix into in its echelon form. So Gauss elimination method. So we have to convert the given matrix into in its echelon form. So these are the diagonal elements. So these are the diagonal elements 0, 2, 0, minus 5. So 0, 2, 0, minus 5. So now interchanging first row with last row because starting element is not is equal 0 because the diagonal elements must be non-zero. Starting diagonal element is 0. So that's why we are interchanging R1 interchanges R2 R, R2 interchanges to R3 like this. So first row is interchanges to last row. So R1 is interchanges to R4. So that is 6, 1, minus 6, minus 5, 6 becomes first row. So first row becomes last row. 0 to 0. So this is plus 1. Plus 1, 0. So after interchanging. So next, so using first row first element. The first row first element must be 1. And also using first row first element to make all other elements in first column is equals to 0. To make all other elements in first column is equals to 0 by using row operations only. Next, similarly, using second row second element to make all other elements in second column to make all other elements in second column equals to 0 by using row operations. Next, using third row third element to make all other elements in third column equals to 0, and using fourth row fourth element to make all other elements in fourth column should be 0. So but here in first row first element should be 1. All the diagonal elements are should be 1. So that's why we are divided by 1. Now perform 1 by 6 into R1. So 1 by 6 into R1. So we get. So that is, so first row is divided by 6. First row is divided by 6. So here 1 by 6 minus 1 and minus 5 by 6, 1. So this is first row. Next, to make, so now we have to convert the given matrix into in its echelon form. So echelon form is nothing but all diagonal elements are non-zero, remaining elements all are zeros. So here these are the diagonal elements. To make all other non-diagonal elements like this, minus 1, 6, minus 5, 3, 2, 1, 0, like this. These all are to make other elements are zeros by using row operations only. So here using first row first element, to make all other elements in first column should be 0 by using row operations only. So but here last element is 0 now. Last element is 0. Now we have to convert these two elements like 2, 4. Elements must be 0 by using row operations only. So that is first row operation, R2 tends to R2. Second row minus 2 into R1. 2 into R1. So this is first row operation. So next R3. Here 4 is there. So first row is multiplied by 4. R3 tends to R3 minus 4 into R1. So R2 tends to R2 minus 2 into R1. R3 tends to R3 minus 4 into R1. Then the above matrix becomes, so first row first element is non-zero. Remaining all are zeros. Remaining all are zeros. So after making row operations, so these minus 2, 4 are zeros. So next 1, 0.16 minus 1, 0. First row no change. First row and last row there is no change. So but second row is changes to R2 tends to R2 minus 2 into R1. Next R3 tends to third row. R3 tends to R3 minus 4 into R1. So it will becomes 1, 0, 0, 0. Next. Applying partial pivoting through R23 to make A22. In numerically largest in the row, you will get it. You will
Sir, I
get.
have a doubt.
చెప్పండి.
సార్ ఇది R2 tends to 2R1 కదా సార్, అంటే 2 R సెకండ్ రోని మనం కన్వర్ట్ చేస్తున్నాం కదా.
Second row minus 2 into R1. Second row minus 2 into R1. So like this. R2 tends to R2 minus 2 into R1. So R2 tends to R2 minus 2 into R1. So this is second row operation. R2 tends to R2 into R1.
We do subtraction, then it becomes
Then it will become 0. So we have to convert the given matrix into echelon form. So echelon form is nothing but to make below diagonal elements all are zeros. Simply to make below diagonal elements all are zeros using diagonal elements. So using first row first element to make all other elements in first column should be 0. So here 1, remaining all are zeros. So similarly remaining also to make all other zeros is nothing but like this. This one. This is final matrix. So these are the diagonal elements. Echelon form is nothing but all the diagonal elements are non-zero, all other elements other than diagonal elements are zeros. That is, so this is echelon form. Echelon form is nothing but diagonal elements are zeros, non-diagonal elements all are non-zeros. Okay. So directly here, there is no need to interchange these two. There is no need to here interchanges to R2 interchanges to R3, but no need, directly we can do. So here next, to make using second row second element, using second row second element to make all other elements in second column should be zero. So that is, so here to make all other elements in second column should be zero. So that is R1. R1 tends to, so multiply opposite 1.667 into R1 minus, so 0.166 into R2. So these are multiplied by opposite. So these are multiplied by opposite. So then we can subtraction. R1 tends to, so 1.66 into R1 minus 0.166 into R2. So then it will become 0, first element. So next second element. So these are multiplied by R2, opposite. R3 tends to 1.66 into R3 plus minus 3.66 into R2. So here also 0. So next this one. So this is R4 tends to, so 1.66 into R4 minus 2 into R2. So then here 0, 1.6. These are multiplied by opposite. So this is into R4. This is into R2. So subtraction, then we will get 0. So this is non-zero, remaining all are zeros. So similarly, third element also. After that, after this, so we are getting this matrix. So here, these are the non-zero diagonal elements. So similarly here also, R3, using third row, third element, using third row, third element to make above and below elements. So that is, all the elements in third column should be 0, using third row, third element to make all other elements in third column should be 0. So by using row operations only. So first row is multiplied by 15 and third row is multiplied by minus 1.5. So adding these two, we will get 0 on here. Here also. So multiplied by opposite. So this is multiplied by 2.99. So this is multiplied by 15. So that is, for example, so R1 tends to 15 into R1 plus minus 1.5 into R3. So minus 1.5 into R3, then we in first row, third element should be 0. After doing this row operation, first row, third element 0. Here also same. So 0, 1, 2.999. So this is also multiplied by opposite. So R3 tends to, R2 tends to 15 into R2 minus 2.99 into R3. So 15 into R2 minus 2.99 into R3. Then here, after this row operation, so second row, third element also 0. Second row, third element also 0. So next, last row. So last row, this element. So these are multiplied by opposite. So that is, third row is multiplied by minus 15 minus 5.99 into R3 plus 15 into R4. So then after this row operation, fourth row, third element also 0. Next, last one, R3 tends to R3 by 15. Then we are getting here 1, 0, 0, 1. So this is, now apply 1 divided by 15 into R3. So we are getting, so this final answer 0, 1, 0, 0, 0, 0, like this. So this is the solution for given matrix. So this is x4. So this is x1, x2, x3, x4. So this is the solution for in Gauss-Jordan method. So this is simple method. So to convert the given matrix in its echelon form. So to convert the given matrix into echelon form, so first we can mark diagonal elements. So these are the diagonal elements. So to make below and above diagonal elements all are zeros. To make below and above diagonal elements all are zeros. So by using row operations only. By using row operations only. Is clear? So this is
ఇంటర్లో
called,
ఉంది చూడండి సార్, అట్లే కదా సార్, సేమ్.
yeah, interloan, echelon form. So this is called echelon form. Same, inter row operations only. So these are the x1, x2, x1, x2, x3, x4 values here. So this is x1 minus 0.499. So this is x2, this is x3, x4. Same inter problem. Next, Jacobian and Gauss-Seidel iteration methods. Jacobian iteration method. In Jacobian iteration method, so here, so this is important one. X k plus 1. X k plus 1 is equals to h into x power k. X k plus 1 is equals to h x power k plus c. C is nothing but constant. So k is equals to 0, 1, 2, 3. And where h is equals to minus d inverse into L plus u, minus d inverse into L plus u, comma, c is equals to d inverse into b. So L is nothing but lower triangular matrix, U is nothing but upper triangular matrix, T is nothing but diagonal matrix. So these are the formulas. X k plus 1 is equals to h into x power k plus c. So this is iteration process. If k is equals 0, we are getting x1. K is equals to 1, we are getting x2, x3, x4, like this. So where h is equals to minus d inverse into L plus u. L is lower triangular matrix, U is upper triangular matrix, and D is diagonal matrix, and C is equals to into B. C is equals to D inverse into B. So for example, so this example, solve the system of equations using Jacobi iteration method. So he is given three system of equations. 8x1 plus x2 minus x3 is equals to 8. 2x1 plus x2 plus 9x3 is equals to 12. x1 minus 7x2. So these are three system of equations. Now, system of equations in matrix form. So first we can write matrix form 8, 1, minus 1, 2, 1, 9, 1, minus 7, 2. So this is matrix. So given system of equations in matrix form, coefficients x1, x2, x3, x1, x2, x3, x1, x2, x3. So diagonal matrix is nothing but reverse of x1, x2, x3. x1, x2, x3. So these are the given system of equations. So system of equations in matrix form. So here diagonal elements are 8. First element 8. So next second element minus 7. Last element is 9. 8 minus 7, 9. So D matrix is nothing but in the system of equations, the diagonal elements 8 minus 7, 9. So these are the diagonal elements. So this is D matrix. So next, L is nothing but lower triangular matrix. Lower triangular matrix is nothing but below diagonal elements. Below diagonal elements is nothing but these are. So below diagonal elements is nothing but x1 coefficient 1. Here third row x1 coefficient is 2, comma 1.
Sir,
So 1, 2, 1.
సార్ ఒక డౌట్ సార్,
చెప్పండి.
ఇది 2, 3ని ఎందుకు చేంజ్ చేశారు సార్?
ఎక్కడ
ఇక్కడ R2 R3ని చేంజ్ చేశారు.
డైరెక్ట్ చేసినా వస్తుంది, మీకు ఎలా చేసినా వస్తుంది, ఇంటర్చేంజ్ చేయకుండా వస్తుంది.
ఓకే సార్,
ఇష్టం అది. సిస్టమ్ ఆఫ్ ఈక్వేషన్స్ ఎలా అని తీసుకోవచ్చు. నో నీడ్ టు ఇంటర్చేంజ్, వి కెన్ డూ డైరెక్ట్లీ. ఇక్కడ ఇంటర్చేంజ్ చేశారు కాబట్టి మళ్ళీ అలా చెప్తే వేరే వాల్యూస్ ఉంటాయని చెప్పేసి డైరెక్ట్ ఇలానే చెప్తున్నాను. సో లోయర్ ట్రయాంగులర్ మ్యాట్రిక్స్ 1, 2, 1. రిమైనింగ్ ఆల్ ఆర్ జీరోస్. డయాగోనల్ ఎలిమెంట్స్ ఆర్ జీరోస్ అండ్ రిమైనింగ్ అప్పర్ ట్రయాంగులర్ ఎలిమెంట్స్ ఆర్ జీరోస్. నెక్స్ట్ U, upper triangular matrix. So upper triangular matrix is nothing but, so these are. So these elements 1, -1, 2, 0, 0, 0, 0, 1, -1, 2. So this is the upper triangular matrix. Diagonal matrix, lower triangular matrix, upper triangular matrix. So based on given system of equations, based on given system of equations. So next, D inverse. So D inverse is equals to 1/8 minus 1/7, 1/9. So D inverse 1/8 minus 1/7 interchanging. Inverse matrix minus 1/9. So next, L plus U. So here formula H is equals to formula X K plus 1 is equals to H into X power K plus C into plus C. K is equals 0, 1, 2, 3. H is equals to minus D inverse. We know D inverse matrix. And we can add L plus U. And also we have to find out C matrix. C is equals to D inverse into B. D inverse into B. So first we have to find out H matrix. So minus D inverse into L plus U. So L plus U. L plus U. L plus U. Adding these two matrices, we are getting, so 0, 1, minus 1, 1, 0, 2, 2, 1, 0. So then H is equals to minus D inverse into L plus U. So multiplying these two matrices and multiplied with minus. So we are getting H value. H is equals to minus D inverse. So this matrix into L plus U. So this one. So first matrix into second matrix, multiplying these two with minus negative term. So this is H value 0, minus 1/8, 1/8, 1/7, 0, 2/7, minus 2/9, minus 1/9, 0. So this is H matrix. The next C. C is equals to D inverse into B. Formula C is equals to D inverse into B. So D inverse matrix 1/8, 0, 0, 0, minus 1/7, 0 into B matrix is nothing but, so here, so B is nothing but these values 8, minus 4, 12. So this is B matrix 8, minus 4, 12. So multiplying D inverse into B. So multiplying D inverse into B. So we are getting 1, 4/7, 4/3. So this is C matrix. The next, iteration process. So the iteration equation can be written as x power k plus 1 is equals to h into x power k. So this is H matrix, h into x power k plus C. So this is C matrix. So there is no initial approximation. So there is no initial values. So there is no initial approximation. So we can take zeros, x0, 0. So that is x power 0, 0, 0, 0. So there is no initial approximation, that is 0, 0, 0, then x1. So put k is equals to 0 in this equation. put k is equal 0 in x power k plus 1 h into x power k plus c. So in this equation, put k is equals to 0. So we are getting x power 1. So that is x power 1 is equals to x power 1 is equals to, so this is H matrix. So x power 0, there is no initial approximation. X power 0 is not given. So we are taking 0, 0, 0. X power 0 is nothing but 0, 0 is given here. There is no, since there is no initial approximation solution. So that's why we are taking x of 0 is equals to 0, 0, 0. So that's why 0, 0, 0 plus C matrix. So we can add these two matrices. So x1, first iteration, 1, 0.57, 1.33. So next, put x is equals to, put k is equals to, put k is equals to 1. Put k is equals to 1. We are getting second iteration. Second iteration, x2 is equals to, so this is H matrix. This is H matrix x1. Here x1, so here k is equals to 1. K is equals to 1, x2. So that is x2. So this is H matrix after simplification. And here x1. So but x1 is nothing but previous value. So 1, 0.5, 1.33. And C matrix. So we can add these two after multiplication. We can add these two matrices 1.0, 0.9, 1.04. So this is second iteration. So next, put k is equals to, put k is equals to 2. We are getting x3. Third iteration of third approximation or third iteration. K is equals to 2. X3 is equals to, so this is H matrix and x2. So previous approximation plus C matrix. So next here, so this is x3. So next we can calculate x4. So calculate up to any two iterations are nearly equal. So continue this process. Any two iterations are nearly equal. Nearly equal. So x4, k is equals to 3. So this is H matrix, x3 plus C matrix. C matrix. So add 1.9, 0.9, 0.9. So next x5. So compare previous values, these two values. So 1.9, 1.0, 0.9, 1.0. So 0.9, 0.9. So only third value nearly equal, 0.9, 0.9. So next we can compute at least five iterations. So x5 is equals to H matrix x4 plus C matrix. So we can multiply 1.0, 0.9, 1.0. So similarly, we can compute x6 also. x6 and x5. x6 and x5 are nearly equal. 1, 1. 1.0, 1.0 and 0.9, 0.9. So last also 1.0. x5 and x6. These two iterations are nearly equal. So therefore, the solution of the system of equation x1 is equals to 1.0, x2 0.9, x3 is equals to 1.006. Is clear? So continue this process up to any two iterations are nearly equal. Nearly equal. Okay. So this is the iteration method. So any doubts? Jacobi iteration method. So formulas. So this is the formula for Gauss Jacobi iteration method. X power k plus 1 is equals to h into x power k plus c. K is equals to 0, 1, 2, where h is equals to minus d inverse L plus u. D inverse into L plus u, comma, C is equals to D inverse into B. C is equals to D inverse into B. So D is nothing but diagonal matrix. D is diagonal matrix, L is lower triangular matrix, U is upper triangular matrix. So B is nothing but constant matrix in given system of equations like AX is equals to B form. AX is equals to B. So B is nothing but constant matrix. So this is the formulas for Jacobi iteration method. So next, Gauss-Seidel method, Gauss-Seidel iteration method. Here also same formulas. So x power k plus 1 is equals to h into x power k. So same formula, x power k plus 1 is equals to h into x power k plus c. So but here h and c values are different in Jacobi method and Gauss-Seidel method. In Gauss-Seidel method, h is equals to minus d plus u whole inverse. D plus u whole inverse into u. You know, diagonal matrix plus lower triangular matrix addition d plus u d plus l whole inverse into upper triangular matrix, and c is equals to d plus l whole inverse into b. So this is c matrix and h matrix. There is a slight difference in Jacobi iteration method and Gauss-Seidel method. In Gauss-Seidel method, h is equals to minus d plus l whole inverse into u, and c is equals to d plus l whole inverse into b. In Jacobi iteration method, h is equals to d minus d inverse into l plus u, minus d inverse into l plus u. C is equals to d inverse into b. So these are the different. Same formula. X power k plus 1 is equals to h into x power k plus c. Example. Same example. 8x1 plus x2 minus x3 is equals to 8. x1 minus 7x2 plus 2x3 is equals to minus 4. 2x1 plus x2 plus 9x3 is equals to 12. So the system of equations in matrix form. The system of equations in matrix form: 8, 1, minus 1, 1, minus 7, 2, third row, 2, 1, 9. So these are unknown values, x1, x2, x3. So these are constants, 8, minus 4, 12. The system of equations in matrix form. Next. So compare this equation with Ax is equals to B form. Ax is equals to B form. So where A matrix, this one, X matrix and B matrix. Here it follows that A matrix, B matrix. So next. So diagonal matrix. Here diagonal matrix is nothing but. So these are diagonal matrix 8, 0, 0, 0, minus 7, 0, 0, 0, 9 is not given here. So this is diagonal matrix 8, 0, 0, 0, minus 7, 0, 0, 0, 9. So this is diagonal matrix. So we can add D plus L. L is nothing but lower triangular matrix 1, 2, 1. Remaining all are zeros. Lower triangular matrix. So below diagonal elements like 1, 2, 1. Remaining all are zeros. Okay, na? So this is next D plus L. Diagonal matrix plus lower triangular matrix. That is only we are getting upper triangular matrix elements all are zeros. So 1, minus 1, 2. In place of 1, minus 1, 2, we are writing directly 0. So this is D plus L matrix. D plus L. So next, D plus L whole inverse. So D plus L whole inverse is nothing but, so we can write inverse of matrix. Inverse of matrix, how to find out inverse of matrix? Adjoint of A by determinant of A. A inverse. A inverse is equals to adjoint of A by determinant of A. First we have to find out D plus L determinant. If the determinant is not is equals to 0, then inverse is exist. If the determinant is equals to 0, there is no inverse exist. There is no inverse. So therefore, Gauss-Seidel iteration method is not applicable for given system of equations. If the determinant is 0, not applicable. If the determinant is not is equal 0, then so A inverse is equals to adjoint of A by determinant of A. D plus L whole inverse. So inverse of A, D plus L. 1 by 8, 0, 0, 1 by 56, minus 1 by 7, 0. So third row, minus 5 by 168, 1 by 63, 1 by 9. So this is D plus L whole inverse. Next H value. H is equals to minus D plus L whole inverse into U. So D plus L. So D plus L whole inverse. This matrix is multiplied by U matrix. U is nothing but upper triangular matrix. After multiplication, we are getting this value. 0 minus 1 by 8, 1 by 8, 0 minus 1 by 56, 17 by 56. So this is H matrix. So this is H matrix. So C is equals to, is given C. C formula. C is equals to, so D plus L whole inverse into B. D plus L whole inverse into B. So this is multiplied by B. So this matrix is multiplied by, so this B. So we are getting C. C is equals to D plus L whole inverse into B. Multiplying these two matrices, we are getting C value. So that is formula. X K plus 1 is equals to H matrix. So this is H matrix. H is equals to minus D plus L whole inverse into U. So that is H matrix into X power K plus C matrix. C is equals to this one. C is equals to D plus L whole inverse into B. So that is C matrix. X power K plus 1 is equals to H. X power K plus C. Here also same. So there is not given initial approximations. So X power 0 is always 0. X power 0 is equals to 0, 0, 0. So put K is equals 0. In this equation, K is equals 0. We are getting X1. X power 1 is equals to, after simplification of this matrix, H matrix. So X of 0 is always 0, 0, 0, 0 plus C matrix. So adding these two matrices, so we are getting 1, 0 0.7, 1.0. So this is first iteration values. So next, in second iteration, put K is equals to 1 in this equation. Put K is equals to 1 in above equation. So we are getting X2. X2 is equals to H into X1 values. X1 is the here. X1. X1, 1, 0 0.7, 1.0 plus C, this matrix. So multiply these two matrices and adding C. So we are getting 1.0, 1.0, 0.9. So next, so this is X2. Next X3. So compare X2 and X1. So here different values are there. 1.0, 0.7. So next we go to X3. So put K is equals to 2. In the above equation, X3 is equals to H into X2. So this is X2 value. X2 plus C. So that is X3. So next, similarly X4. X4 is equals to, put X is equals to K. In the above equation, X4 is equals to H matrix into X3. X3 into plus C matrix. Here 1.0, 1.0, 0.9. So these are similar to X3. So 0.9, 1, 0.9, 1. So 1, 0.9. Or we can compute another iteration also, X5. So we are getting same values. So that is X1 is equals to X1, 1, X1 value 1, X2 1, X3 also 1. So 0.9 is nothing but here taking only one value. So 1, 1, 1. So this is the solution of given system of equations in Gauss-Seidel method. So these are the two methods, Gauss-Seidel and Jacobian method. Inverse of a matrix. Inverse of a matrix. Direct method for computing the inverse of a matrix A. So inverse of a matrix is formula A inverse is equals to 1 by det A into adjoint of A. So 1 by det A into adjoint of A. Find the inverse of a matrix by direct computation. So this is the A matrix 1 2 minus 1 3 6 1 3 3 2. So first we have to find out cofactor matrix. Cofactor matrix of given matrix. So this is given matrix. First we have to compute cofactor matrix. So cofactor matrix is nothing but, so this is matrix. So first we can take signs. First plus, minus, plus, minus, plus, minus, plus, minus, plus, up to last row. Alternative, plus, minus, plus, minus, plus, minus. So next, here, first row, first element. First row, first element cofactor. So row, column, cancel. So 6 into 2, 12 minus 3. Determinant of 2 by 2 matrix. 12 minus 3. That is 9 plus 9. So next. So 9. So next here. Second row, second element. So cross out. Second row, first column. First row, second column. So we are getting 2 by 2 matrix. 3, 1, 3, 2. So 3 by 2 matrix determined. 6 minus 3. 6 minus 3 is nothing but 3. So that is 3. So here 3. Next. Last one. Last. So cancel. Cancel last row, first row, last column. So we are getting 2 by 2 matrix. 3, 6, 3, 9. So that is 9 minus 12. 9 minus 18. So 9 minus 18 is nothing but minus 9. So minus 9. So here minus 9. So this is first row. So similarly we can calculate remaining rows also. So that is here we can see 9 minus 3 minus 9. 9 minus 3 minus 9. So direct method. So remaining also minus 7, 5, 3. 8 minus 4, 0. Same process. So this is the cofactor matrix. So adjoint of a matrix is nothing but cofactor matrix transpose. So the transpose of cofactor matrix, adjoint of A is equals to cofactor matrix transpose. So interchange first row as first column. 9 minus 3 minus 9. So second row as second column. Second row as second column. So that is minus 7, 5, 3. Next last row is last column. 8 minus 4, 0. So that is, the determinant is 12. Determinant is 12. So adjoint of A is A inverse is equals to adjoint of A by det A. So adjoint of A is equals to 1 by 12 into, so this is adjoint of A matrix. So this is A inverse. Is clear? Formula adjoint of A by determinant of A. So inverse of a matrix. So next, Gauss-Jordan method. So in Gauss-Jordan method, using Gauss-Jordan method to find the inverse of a matrix. Find the inverse of a matrix by using Gauss-Jordan method. So write the augmented matrix AI. A matrix comma I. I is nothing but identity matrix. I is nothing but identity matrix. Is clear? A matrix is nothing but is given matrix, and I is nothing but identity matrix of order minimum 3 by 3. 1 0 0 0 1 0 0 0 1. So that is A matrix. So this is A matrix. I matrix is nothing but 1 0 0 0 1 0 0 0 1. So now we can convert this matrix into echelon form. So echelon form is nothing but to make all below diagonal elements and above diagonal elements all are zeros by using row operations only. To make above and below diagonal elements all are zeros. So by using row operations only. So first row operation. So here first row first element is non-zero. So using first row first element to make all other elements in first column should be zero. So that is first row operation R2. R2 tends to 4 into R2. R2 tends to R2 minus 4 into R1. So first row is multiplied by first row is multiplied by 4. R2 minus 4 into R1. So this element should be 0. Next, last one. So to make this element as 0, so that is R3 tends to R3 minus 3 into R1. First row is multiplied by 3 and subtraction. R3 minus 3 into R1. So that is here. This one. After doing 1 0 0 to make these two elements are zeros. 1 0 0 remaining elements 3 by 4 minus 1 by 4 1 by 4 5 by 4 1 0 0. So next, so using second row second element to make all other elements in second column should be 0. Using second row second element to make all other elements in second column should be 0. So that is here. After the row operations, second column. After the row operations, this one. So next also, using third row third element to make all other elements in third column should be 0. So that is R2 tends to R2 multiplied by opposite. So this is multiplied by 10. This is multiplied by 4. This is multiplied by 10. This is multiplied by 5. So like echelon form, to make above and below diagonal elements all are zeros. To make above and below diagonal elements all are zeros. That is. So these are the diagonal elements. So above diagonal and below diagonal elements all are zeros. So this is the inverse of a matrix. So this is inverse of a matrix. Is clear? To convert given matrix into in its echelon form. To convert the given matrix into in its echelon form is nothing but using diagonal elements to make all other elements should be 0. To make all other elements in given matrix should be equals to 0. So this is the inverse of a matrix. So this is inverse of a matrix. Next method, LU decomposition method. LU decomposition method. L is nothing but lower triangular matrix. U is nothing but upper triangular matrix. So these are L values. L. L11 0 0 0. L21 L22 0 0. Up to LN1 LN2 LMN. So this is upper triangular matrix. U11 U12. So in lower triangular matrix, so diagonal elements are L11 L22 up to LMN. Here diagonal elements are there in only lower triangular matrix in this method. So upper triangular upper triangular matrix U11, U12 up to U1n, U22, so like this. So these are the upper triangular and lower triangular matrices. So inverse of a matrix. So inverse of a matrix formula, A inverse is equals to U inverse into L inverse. A inverse is equals to upper triangular matrix inverse into lower triangular matrix inverse. Using LU decomposition method to find the inverse of a matrix. A is equals to 1, 1, 1, 4, 3 minus 1, 3, 5, 3. So A is equals to L into U, upper triangular matrix into lower triangular matrix, A matrix. So this is L matrix. L11, 0, 0. L21, L22, 0. L31, L32, L33, 0. 1, 1, U12, U13, 0, 1, U2, U23, 0, 0, 1. Okay. So next, multiplying these two matrices equating to A matrix, multiplying these two matrix and equating to this matrix. So we are getting L11 value, L22, L33. So these values, L11 values and U values, L values and U values. So for example, so multiply this one, L11 into 1, L11. So remaining all are zeros. L11 is equals to 1. Next, similarly, L11 into U12. Remaining all are zeros. L11 into U12 is equals to 1. So that is U12 is equals to 1. So next, L12, L11 into U13. L11 into U13 is equals to 1. Remaining all are zeros. So that is L13 is equals to 1. So we can calculate similarly after multiplication equating to A matrix. So 4 is equals to L21. 4 is equals to L21. So that is L21 into U12. L21 into U12 plus L22 is equals to 3. So we are getting L22 is equals to minus 1. So multiply these two matrices and equating to each and every term of matrix A. So we are getting L matrix sign, L matrix 1, 0, 0, 4, minus 1, 0, 3, 2, minus 10. Q is equals to 1, 1, 1, 0, 1, 5, 0, 0, 1. So this is L matrix and Q matrix. Next, find the product of U inverse into L inverse. This gives the required matrix of A inverse. Okay. So we can calculate L inverse, U inverse. Next, multiply U inverse into L inverse. This gives the required matrix A inverse. So is not given L inverse and U inverse. We can find out L inverse and U inverse and multiply L inverse into U inverse. You will get A inverse of a matrix. So this is also same. Example 2. Example to A matrix. So 1, 1, 1, 4, 3 minus 1, 3, 5, 3. So writing A is equals to L into U. With U, 1, 1 is equals to 1. So we get A matrix, L matrix into U matrix. Same here also. Multiply L and U matrix. Equating to matrix A, we are getting L11. So first row is multiplied by first column. So we are getting L11 is equals to 1. Next, L22 is equals to 1. Same question now. Same question. After multiplication, we are getting previous example, same example. L matrix and U matrix. So Next, inverse. Obtaining L inverse. So writing A into lower triangular matrix. A lower triangular matrix x11, x21, x22, x31, x32, x33 is equals to 1 0 0 0 1 0 0 0 1. After writing the equation and equating the matrix, we are getting L inverse. L inverse is equals to, so this is L inverse. Similarly, upper triangular matrix into y11. So we are taking, so this is assumption only. So this is U. So this is U. So we can multiply these two matrices. So equating after multiplication, equating each and every term, we are getting U inverse. So that is the required matrix A inverse is equals to U inverse into L inverse. U inverse matrix and L inverse matrix. So this is the A inverse matrix in LU decomposition method. So this is very important method for short question. LU decomposition method. So this is totally chapter number 5. Total chapter number 5. System of linear equations. System of linear equations. Gauss-Jordan method, Jacobi, Gauss-Seidel method, matrix inversion, direct method, and LU decomposition method, Gauss-Seidel method. This is the chapter number 5, system of linear equations. In next class, eigenvalues and eigenvectors and system of non-linear equations. We will continue on next class.